Hello friends, welcome to Joy of Life. So today we are going to look at another medium level problem from Leetcode. The problem number is 5, longest palindromic substring. So given a string S, return the longest palindromic substring in S. So you'll be given with a string as you see in the example over here. So here is one of the input string BA. So there are two palindromes which are of size 3. Of course there are smaller palindrome than that, but the biggest one we can see is BAB and ABA, right? Both are of size 3 as you can see. So you can return either of the one. So BAB or ABA, both are valid answers. So we need to identify the longest one and we need to return that back, right? So the string could be of size 1000 characters also. So there is a possibility that you get a very big string wherein you have multiple palindromes, and essentially what happens in a brute force algorithm for a problem like this in Leetcode is that you will often get a timeout, right? So we are going to see an approach which is pretty much optimized, and we are going to come up with the code as well for the same. So here is another example that you need to understand over here, that we have a string like A and C, right? So a single character by default is a palindrome, right? If I take the character A, it is A from both front and back, right? It's the same, right? So here we have two palindromes A and C, both are of size 1. You can return either. So here the output is A, it could be C either. There is no harm in sending C back. But yeah, we have to return the longest one. So in this case above as well, what we have seen is that there are this B and A itself is also a palindrome, right? So this B, A, D, these are all single character palindromes as well. But the longest one we see is that BAB. So we need to return BAB or ABA, either of the one, which are of size 3, right? So yeah, we are going to check out the solution, but as I always recommend, do give it a try yourself. To try to solve the problem, at least try the brute force approach, and then we are going to see the optimized approach over here. There are multiple ways to solve it, and we are going to check more than one solution for it. Maybe I'll create 2 separate videos for the same, but let's head over to Leetcode and check out the solution. So in the previous problem, we have seen this solution over here, right? Which was a pretty decent solution where we started from the middle and we moved towards both the ends to come up with a solution, right? So in this video, we are going to check out another solution, which is a dynamic programming solution. And we are going to see how it works in all the details. And though it is not as efficient as this one, because that's once again an order of n square solution. But having said that, what we do over there is we do not check for the palindrome again and again, right? We don't. Here also we have started from the middle, we have expanded, we have checked and done so many things, right? We are not going to do all those things in a dynamic programming problem. We are going to understand the trick behind the same, why we are, how we can eliminate completely the checking off of the palindrome part, and how we can leverage on the sub problems and come up with the solution, right? So in this solution, what we are going to do is, since it's an order of n square solution, that means we are going to check all the possible strings that is present over here, right? But how we are going to save time on that, let's understand that part, right? So we have taken the same example once again over here, right? So it's a so what we are going to do is we are going to create a so-called dynamic programming table. That's the typical part, but we are going to understand the thought process and every minute details behind what we are doing, why we are doing, how we are doing. We are going to cover everything. We are not going to leave anything behind, right? So let's understand the thought process behind this dynamic table, how we are creating it, right? So these are all the possible substrings that's possible from the string BABAD. So there are 5 strings that's possible from B, starting with B, like BA, BAB, like B, then BA, then BAB, then BABA, then BABAD, right? So these are the 5 strings. And if you start with 1, then you can have A, then AB, then ABA, and ABAD, and so on, right? So there will be 5, then 4, then 3, then 2, and then finally 1. So these are the all substrings, right? And that is why we have order of n square, right? Because we are generating all of them, right? So let's understand this table in much more details, this dynamic table. So what it does is it tells me the starting index and the end index. So if I have to mark over here, so let's say this is my start index and these are my end index. So this cell signifies that 0 to, so this cell over here, the one the one that is highlighted, right? So this cell over here signifies that it's the substring starts at 0, ends at 2. So 0 to 2 means BAB, right? So 0 to 2, if you check over here. So this is 0, this is 2. So 0 to 2 means BAB, right? So see over here 0 to 2. So this cell signifies this substring. This cell over here signifies 0, 0 means only this. This cell similarly signifies the starting index 0 and the end index is 3. So B, A, B, A, B. So it's denoted by this character. This cell over here, starting index 3, which is a, and ending index is a 3, which is the same index. And this is AD, like that. So essentially what happens is these indexes, like starting 1, ending 0, we cannot ever have a substring like that, right? So this is invalid, right? We cannot have a cell like this, right? Similarly, all these cells over here becomes an invalid cell. So as we have discussed earlier, we know that the single character is always a palindrome. So what we can say that starting at 0, ending at 0, it's a palindrome. Yes, it's a palindrome. True, it's a palindrome. Starting at index 1, ending at index 1 means a single character. It's also a palindrome. So all these cells starting and ending at the same index becomes our palindrome, right? We can say that easily. So what we are basically doing is over here, we are establishing our base cases, right? In a dynamic problem, we first establish the base cases and then we build on top of the base cases, right? So a single character is our base case and two characters is also our base case. So what we are going to do over here is we are going to check that is B and this A same. So 0 and 1, right? Over here, starting at 0, ending at 1. So starting at 0, ending at 1. Is B same as A? So we are just comparing a single character. And we see that it's not. So we are going to put a false. So let's put the false one with a different color so that it becomes easier for us to identify. Is B and A same? No. Is B and is A and B same? No. Is B and A same? No. Is A and D same? No. So now we have established our base cases, and now what we are going to do is we are going to fill up the rest of this table and we are going to see how we are going to fill this up. So let's talk about the odd and the even cases and understand like how they differ in a palindrome. So if I give you a string, right, A, and ask you, is it a palindrome? You will probably say yes, true, it's a palindrome. So if I ask you CAC is a palindrome, so probably you will tell me that yes, it is a palindrome. Now for even, what do we need to do? I'll give you two strings over here, right? And I ask you, is it a palindrome? So you will check both and say it's a palindrome, right? And for a odd, the base case is a single character. For a even, the base case is double character, right? So that's why what we have done is we have filled up both, right? Not only one row. So we have two base cases. One is for a single character, so that was for odd, and the double character, that is for the even size palindrome, right? So now let's build on top of this one. So you said CSE is a palindrome. So if I give you a B and a B, what will you say? You will say it's a palindrome. So let's say it keeps growing and growing and growing. So basically, if you look at the pattern, if you know that this is a palindrome, if you know this is a palindrome and these two characters are same, the new ones are same, that means this is also a palindrome. You don't need to check this part if you already know the answer, right? Same thing goes over here in our table, and same thing happens here also, right? You know A and A is a palindrome. So if I give you a C and C and ask you, you don't need to check A and A because you know. Now the only thing is these two has to match. That's it, right? So that's all the subprobleming is all about. So if you take a palindrome like A, B, C, D, C, B, A. So I have first found this is a palindrome. Then I checked this. I did not check the middle because I know the middle is already true. I again check these two. I know the middle is already true. So that's how you are capitalizing on your subproblem. That's why you are reusing your subproblem. So over here, now when you come over here, so when you check this A and D, right, you don't have to check from A is matching or not and all that. So the moment you see that A and, so you're going to put a F right away. And do keep in mind, we are going to fill it up bottom up because the bottommost line over here has been completely filled because of the nature. The bottom two lines are completely filled because of this principle. Because however big your string is, your last two substring categories will be one and two characters only. The higher you go, the more number of substring you will end up having, right? So over here, the moment I see A and D is not same, I'm going to say I'm not going to check anything else. It's not a palindrome, right? So let's move on. So let's understand this cell in a little more details. So what does this cell signifies? It starts from the A and it ends at A, right? So this A is the first index A and this A is the third index A. It's not the same A. Okay. So it's basically the substring that we are talking about is a B, A, right? So again, we are going to check that first index and third index is it same? Yes, they are same. A and A is the same. So my condition over here is these two, the edge two characters I have checked and that is true. Now whatever is in the middle, I need to verify that one. And how do I verify that one? Basically, I have to just check for this cell over here, right? So let me put the index for this cells. So this is 1, this is 2, and this is 3. So if I remove, what I am left with is a 2 and a 2, right? This is a 2 and a 2. So I just reduce 3 by 1 and increase 1 by 1, right? Because if you remember, however big we have a string, let's say this is a string, right? I know this is palindrome, right? I first knew this is palindrome, then I knew this is palindrome. Now I know this is palindrome. So had this been a, what I need to do is I have to check the substring 0 plus 1 and 6 minus 1. So basically 1 to 5. And here what will happen? We have to check 2, 2. And where is, we'll go to the cell 2, 2, which is already being calculated for us. We are going to get the value and do a AND between them. So I see this is also true, right? So what will happen is this cell over here will get the value directly. So this cell will get this true value from here, right? Again, for A and D, what we see is that it's not the same. A and D is not the same. So we are getting a false over here. Going to this cell over here. So what is this cell? This cell is B. So let me put it over here. So this cell signifies BAB, right? So this B and this B is matching. Again, they are of not the same index. So now I'll reduce 1 from 2 and increase 1 from 0. So I will go to the cell 1, 1 and get the value. So 1, 1, I see a value which is true. So I know that this value is going to be true. And these two will definitely be false because A and B is not the same. So we are getting a false over here. And B and D is not the same. So we are getting a false over here. Now the problem is very simple to figure out the biggest palindrome that we have. So we leverage the same loop in order to find out where we have seen the biggest root, right? So over here I have seen in the cell 2. So I know that this starts from 0. So this is the biggest palindrome I have seen here. Similarly over here at index 3 I have seen, but it starts from 1. So they are basically of the same size. So this guy over here and this guy over here is of the same size. So we know that. So we can take either of the one and we can say that this is the biggest palindrome that we have seen so far. So in this solution that we have discussed, if you see the substrings that we have generated, right, what do we need in order to generate that? So in order to generate this kind of strings, what do we need is two loops. One is I starting from 0 and then going all the way through the string, right? So basically what we are doing is we are iterating over the string twice, right, the entire string twice, and that too in a less nested fashion. So this is going to give you order of n square. But still, why it is better than a naive solution is because we are not doing a check on the string, right? So that is providing us with some advantage that we don't have to compare the entire string because we are kind of pre-computing the result. So each one of this cell over here is a subproblem, right? Each one of this cell over here is subproblem. So if you give me the string BABA and ask me what is the maximum size palindromic substring present in it, still I can tell you the answer because I have solved all the problem along its way, right? I found the answer for everything, every possible substring, and we have built on top of it, right? So that's why we gain certain advantage over here. Though this is not a very optimized solution, right? The optimized solution we have already discussed, and I will leave a link to the description to the other problem in this video as well. So the basic intention of making this video is to give you a very good insight on the dynamic programming part, how dynamic programming can help us in finding the palindromic substrings as well, right? So I hope you got the concept, and we are going to look at another example. If you think that you want to continue watching another complex example wherein we have multiple palindromic substring of different lengths, maybe say length 3 and length 4, and how we are finding out how we are dealing with the even number of characters in a palindromic substring, though it's the same, there is nothing going to be different on that solution as well. But what I recommend, if you want to check out, if you have time, do check it out. If you don't have time, then use the timeline bar below and skip over to the coding part and check out the code for the same. So here I have taken a complex example, but we are going to run a little faster and we are just going to touch upon the important parts where we might face some doubts. So again, once again, if your indexes are like 1 to 0 and all those indexes, we are going to cut them off because we cannot have a substring with the first index greater than the second index, right? So we are cutting them off. So this is 5 and you can see this is 4, right? The first index is higher than the second index. So these are all eliminated. And what we know, this diagonal is just the single characters, like right 0 0 to 0, 1 to 1, 2 to 2, 3 to 3, and all that up to 7 to 7. These are all single characters, and single characters are always true. So this is our base case for the odd number of characters, right? Now we have to set the base case for our even number of characters where we have two characters only. So what we are going to do, we are going to just compare this P with C, C with P. We are not going to check anything else. We are just going to compare these two characters. That's it. Those two characters, starting this and ending. So if you see all these cells over here, they have one difference, 0, 1, 1, 2, 2, 2, 3, 3, 4, 4, 5, and so on, right? So let's fill that up. So P and C is different. So this is going to be false. This C and P is different over here, right? So this is also false. This P and B is different, so this is also false. This B and this S is different, that's false. This S and this S is same, so keep in mind that we might have true cases also. Alright, so this is true. Moving on, this S and this B is different, so this is false. This is now false. So we have established our base cases and we are going to solve from the top down. So we are going to solve now from top up, right? So last two rows are always completely filled. We don't need to take care because the last substring is of one character and the second last substring is of two characters. That's always true, and we don't need to do anything but that, right? So we'll continue over here. So we check directly S and X, they are different, so it's false. So this S and B, it's false. This S and X is false. So I hope you're getting the point that when we are talking about this cell, we are talking about the substring starting from the first S to the B, to the last B. So SSB substring we are talking about, right? So each of the cell, they map to a particular substring over here. So this B and this S is different. So once again a false. Now we are about to hit an interesting case. So this is the first B and this is the last B. So we are talking about BSSB and let's see how this evaluates to be true. So B and B is true, right? Now since B and B is true, so our substring is BSSB. So B and B we have seen that it is true, right? And let's put down the index is 3, this is 6, this is 4 and 5 of course. So what we need to check is we have to reduce from the left boundary 1 and the right boundary because this is the value we are manually checking, right? Now we have to see what is the value in the index 4 5. So 4 is here and 5 is here and we see that it is true. What does the 4 5 value signifies? It signifies the value SS. So you can see here S was true, SS was also true. So 4 5 is true and 3 and 6 are same, right? So we can say that this is a palindrome over here. So moving on, B and X is not same, so it is false. So over here P and S is not same, so it is false, this is false because none of them are P, right? So we can mark them false. Now coming to this in index 1, then we see that C and B not same, C and S not same, C and S not same, C and B not same, C and X not same. So these will all become false, right? Now we come to this cell and you can see that this is the value of PCP, 0, starting from 0, ending at 2. So what happens once again? PCP, starting at 0, ending at 2, 0, 1, 2. So we are going to check 0 and 2. And if we reduce 2 by 1 and increase 0 by 1, what we get is 1, 1. So we are going to see what is there in 1, 1. It's a true we have in 1, 1. So we can safely say that this is also a palindrome over here, right? And the rest of the things we see that P and B different, S and B different, S and P different, B and P different, B and X different. So you can see that we have found a palindrome. So now, so 2 minus 0 plus 1. Why do we do the plus 1? Because we are doing a 0 based indexing, right? We have to increment by 1. So the size is this guy over here. He has a size of 3. This palindrome is of size 3. Over here we have 6 minus 3 plus 1. So 6 minus 3 plus 1, 6 minus 3, and this is 4, right? So we can say this is 4, right? So every time we put a true, we can calculate the value, check the length and store it. So 4 is the best size. And if I store the index, that is this cell denoted, right? So we have 3 to 6. 3 to 6 is nothing but BSSP. We can just put the answer there. So let's move over to Leetcode and check out the solution there. So what we are going to do, as you have seen in the solution, is we have a matrix or a DP table which is of a Boolean nature, right? Because it was all Boolean. We have been storing true or false over there. So we are going to create a Boolean two-dimensional array, and let's call it our table where we'll have the data. And what would be the size of this table? This would be the size of your string, right? So we are going to put s dot length. Right, so this is going to be our table, and what we are going to do is now we need to return the longest palindrome, so let's call that as a result that we'll be finding out, and at the end we'll be returning back, right? And now what we are going to do is first we'll be filling up our base cases. So base cases is the single character and the double character string that we have talked about. So I am going to start the first loop over here. So this loop over here, I can just have a single loop, right? Because we know that we have to deal with the first two indexes from I, right? So for while I is 0, we have to deal with 0, 1. While I is 1, we have to deal with 1 and 2. While I is 2, we have to deal with 2 and 3 and so on. So I don't need two loops over here. So what I'm going to do is I am going to put into the table of I and I. So what we can say is that I and I is always true, right? So this is for the first case where we have the single character. So we certainly know that that's going to be true anyways. The result we have initialized to a blank. Let's not do that. Let's initialize this with the first character of the string, right? Because that's also a palindrome, right? So starting from index 0, and let's pick up one character. And now what we are going to do is we are going to check for the second character. So basically, even if you look at this, so there are few edge cases over here that you need to cover up in this second character basically, right? So one is that for the last character, for the last substring, you won't have a second character also, right? You don't have a place to put that. So you might end up having some array index out of bound exception. So it's better that you put a check over here so that you don't end up hitting that. So checking for s dot length is not sufficient. We have to check for s dot length minus 1, right? We have to reduce one index because I am going to put the value in table I and I plus 1 right over here. So that's why I have to impose a minus 1 over here so that I know that there are at least one more cell present over there, right? So now here what we are going to do is we are going to compare both the characters. So basically character at I. Okay, so we are just checking the ith character and the next character. That's what also we have done over here, that we have checked this and put that right for the base case. So when s and s is same, we put it true. So we can just simply say over here that I plus 1 is equals to char at I and char at I plus 1. So whatever it is, we are going to store it, right? And it might happen that your string is of two characters, and in that case what do you need to do is, if you find a true over here, if this cell over here gives you a true, in that case you have to change your result, right? So we are going to do that. We are going to put if this is true. So we are starting from the ith index and ending at I plus 2 index. We are just picking up two characters, nothing else. What we are going to do is, so we are getting it only when it is a palindrome also, right? So we need to update the result over here. We are going to check the length of both. So string dot length, if it is greater than the result that we have, if it is better than its length, in that case, I am going to go ahead and update my result, right, to str. So this is where I have established my base cases. So both the cases, the odd one, the even one, and also updated the result. That's also very important. These first two diagonals has been populated. Now we have to do a bottom up, right, and fill up the rest of the table. So how we are going to do the bottom up is we are going to start again the loop, but this time what I'm going to do is we are going to start from s dot length minus 2, right? Because the last two row is already filled and I should be greater than or equals to 0 and I plus plus. So this loop will ensure that I'm going from bottom to the to up. and then I have a j, and j will move from left to right, right? That's how we have filled up. So let's do that. So we will start from I plus 2 because I know I and I plus 1 has already been done, right? So for this, we know that I and I plus 1 is already done. So we will start from I plus 2, right? And we will be less than s dot length. So we'll go the entire length of the string and j plus plus. And now what we are going to do is we are going to update our table, and we are going to put the values I and j. And what we are going to do is we are going to first check both the characters are same or not. Two characters are same. So what we have been doing, so we are checking by reducing the left boundary and reducing the right boundary, right? And so how we can find those index is basically we need to go to, so what we are doing over here, so let's understand from here once again. So here we are going to the cell 4 and 5, so we are reducing the row, we are increasing the row by 1, right? So wherever is my I am doing a +1, I'm coming down to the next row because the result will surely be on the next row because that's a sub problem and we are doing a bottom up, right? So if I'm here, my result would be somewhere here, right? Because this is my substring, definitely, because this is cut off, this is I am feeling, so this over here is my substring exactly. So if I am here, this is my substring, if I am here, this is my substring. So if you see in this case also that if I am here, I was checking for this one. So if you remember over here, when we are feeling for this cell 3 and 6, right? So we are feeling for the cell 3 and 6, right? So what we did, we checked for 4 and 5, right? That means one row down, one row left. Don't memorize the pattern, but try and understand the rationale why we are coming one level down. Because if I come one level down and one level to my left, so if I come one cell down and go one cell left, what I will have is basically the shorter substring. So the moment I change the row from 4 to 5, I'm incrementing this value, right? The starting position of the string. So this left edge is getting cut off, right? And the moment I am moving towards my left, that means I am checking for my previous character. So two characters are going off the moment I am coming one cell down and going one cell left, right? So you got the point, right? Just to iterate again, one cell down means I am checking the shorter substring. The shorter substring. So if you see over here, the biggest substring over here is B. So if I talk about this cell over here, so this is BSSBX, right? This is the maximum. But the next one, if you see, it starts from S, right? So SSBX. So the moment you increment I, you are cutting the left. And the moment you go left, you are cutting the right. So one cell down, one cell left, right? So the same thing we are going to do over here. We are going to do a I plus 1, means one cell down, J minus 1. J minus 1, one cell to the left, right? So we got our desired value over here. Now we are going to do the same thing again that we did over here, right? So pretty much the same thing we'll do over here. So let's get it over here. So instead of I plus 1, what I'm going to do is I'm going to say it's J, right? And we are going to get the value of I plus, like will be starting from I and we will be ending at J plus 1. So that plus 1 is always for the zero base index, right? And we get the result in str, and again str.length is greater than result.length. We are going to update the result, and at the end we are going to have the desired result that we want. Let's run the code. I'm not too hopeful, I'll be surely making some errors. I knew it. Basically this will be I minus minus, I shouldn't be increasing it, right? We are going up, right? So finally it worked. Let's submit and check for a broader range of test cases. We have 469 milliseconds over here. So if you remember, we have 23 or 26 millisecond on our previous submission, right? That was far better. So once again, the main intention was to give you the idea on how we can solve such a problem using dynamic programming as well, right? So of course, the solution is not recommended. This is just for your understanding purpose to get some idea on the dynamic programming, how we solve the sub problem and come up with the solution. But it is of course better than your naive solution. wherein you will be comparing all the substring again and again. So it is pretty close to your naive solution wherein we have a order of n square, but at the same time we are leveraging the dynamic programming concept over here in order to not calculate the palindrome or not computing is it a palindrome or not again and again and saving a lot of time. So your naive solution might hit a out of time or out of memory kind of problem, but this solution is will not hit such a criteria over here, right? So this solution has a order of n square complexity both in terms of space and time because we are creating a 2D array of n square, right? It will have if you have n number of elements, it will have n by n size of matrix that you need to populate, right? And you will definitely need two loops over here. So this is your n square part, right? This is order of n because we are just having one loop over here. But this one, though we are saving two rows, that doesn't count. It's a constant. You drop the constant and you take n only, right? N minus 2. So n minus 2 is also n, right? I hope you got the solution. So once again, this was completely for your understanding purpose. I hope you got the concept of how dynamic programming is helping us over here. Probably this will give you some idea wherein you can implement this kind of solution to some other problem, but this is not meant for this problem once again. Okay, so do let me know what do you think about the solution. So don't judge me by the complexity part of this problem. I am not responsible for it. It was just to give you an idea on how things works in dynamic programming, right? I will leave a link to the linear solution wherein we have 23 or 26 millisecond performance, which was better than almost 90% of the submissions. So yeah, that's all from this video. Do share and subscribe if you haven't done so. Also give a like if you think the solution was helpful, and that's all from this video, and see you guys. Stay home, stay safe, and take care. Bye bye.